Hello Algebra 2. Today we'll be talking about Chapter 2, Section 1, Representing Relations and Functions. We'll be looking at the four ways that we know how to represent those functions, identifying the functions, graphing equations with two variables in the three-step process to how to graph those, classifying and evaluating functions, and applying all of this to real-world situations. Now, we first take a look at ordered pairs. When we're looking at ordered pairs, the thing to keep in mind is that we'll always have that x variable or value, the input value, on the left, and the y variable or the output value on the right. So when we know that we're going from ordered pair to a table, we know that we plug into our x column all of our x values that are on the left there. So we just go ahead and fill those in to our table, and this will help us out with our graph. And then we go ahead and fill out the y column with all those right values from the ordered pairs. And we want to make sure that each row corresponds to each ordered pair. So the next thing to keep in mind with tables is we have this thing that we used to call domain. I know you all remember it from Algebra 1. I'm teaching it right now, so I know that you guys learn about it in Algebra 1. Alright, domain. The domain is all of your x values, the whole list of them. Alright, so that is these guys right over here. Then you have this thing that we call the range. And if you guys recall, that was all of our y values. So when we list these out, we need to make sure that our domain in this case would be -2, 0, and 3. Then we have, for our range, we would have -2, 1, and 2. Alright? So the next thing that we're able to do is we're able to move from the table to the graph. So I'm going to go ahead and draw some axes here on my graph. Alright? So we know where we're at when we're doing this. And I know that this is my 1 value, this is a 2, which makes this over here a -1. Right? Same thing going down, -1. 1 going up. If you guys don't ever see a graph labeled, it's generally going by a range of 1 on each line. Alright? So to graph these values, we need to make sure to start with our x. And as we all remember, our x is that horizontal bar, and our y is the vertical bar. Alright? So we start off by going back to our left, and then up to 2, because that's our first point. Then our second point is -2, so we drop down to -2. -2, 2, down here. Then 0, we know we have a point at 0, 1, so it's a little harder to see on this one, but it's right in there. Alright? And then we have our last point, which is 3, 1. Alright, just for this first part, I'm going to plot it. Later on, we'll go into lines and when we connect those points. So then, from the graph, we're going to move to what we call a mapping diagram. Mapping diagram. This is another thing that you guys have probably had some experience with. All you're going to do is show which values go to which. So we know that -2 goes to 2, but we also know that it goes to -2. Which is right here. Just forgot my negative on the PowerPoint. Sorry about that one, guys. Then we know that our 0 goes to 1, and so does our 3. And that's our mapping. It's pretty simple so far. One of the things that mapping really helps us see and understand is why things are functions and why certain things aren't functions. In this situation, the numbers and the points that we have here is not a function. And that is because of this problem right here that I've circled for you. You can never have an input that has two outputs. Another thing that gets really confusing is that this bottom part right in here, this isn't the problem why it's a function. You can have two different inputs or x values going to a single y value or output. If this was the case, and this only, this would be a function. It is because of this top piece up here why we cannot label this set of ordered pairs as a function. Next, we'll be looking at an example. So when we get to this page, if you guys just want to pause and go ahead and try this one yourself. All right, now that we're back after that pause, we can go ahead and begin working this problem. The first thing that this problem asks us to do is to identify the domain and the range. So we're going to go ahead and write it down. Hold on just a second. I'll fix this in. And domain and the range. Apparently I have real problems writing ends. And range. So our domain in this case is going to be all the left numbers inside those ordered pairs. So our first set for domain is -2, and we have a -1, a 1, a 2, and a 3, and a 3. So with our range, as you guys learned, we know that it is the y values, or those right numbers inside those. So we usually label them from lowest to highest. So we're going to get -3. Then we also get -2, which is the next lowest, followed by 1 and then 3. And that is our domain and range. Your guys' answers should look like this, but a little neater, obviously, because you're not doing it on this crazy machine. All right, the next part of this question asks us to go ahead and to graph this. So I'm just going to set up my axes again. All right, and again, since we're going with these numbers, we know that I can just use this simple scale of -1s, -2, and on the positive side, the 1, 2, 3. That's a -2. Alright, so we have a scale like this. Now that we have our scale, since this is our x and this is our y, we know that we can begin blotting these points. So we go back to -2 for the first point and down to -3. So we get a point down here. We go back to -1 and up to 1 for that second point labeled. Over to 1, up to 3 this time. Then we go to -2. We're going over and then up or down. Remember that. Horizontal, then vertical. And our last one, which is 3, 1, we'll put right there. Now, there's a very important piece within this lesson that teaches you guys how to tell through a graph whether or not this is a function. That test is called the vertical line test. And basically what it is if you can put a vertical line through any of these points, if it doesn't touch another point, that vertical line doesn't touch another point, you know that it is a function. So since in each of these values, when we put that vertical line, it doesn't touch another one of our points, we know that this function will be a function. It is labeled as a function. All right? And then the last piece that it asks us is about the mapping. So when we have the mapping, we know that this 2 goes to the 3. We also know that the -1 goes to 1. Our 1 goes to our 3. Our 2 goes to our -2. And our 3 goes to our 1. All right? And again, even though we have the -1 and the 3, the -1 and the 3 going to just this 1, it can still be a function. This can still be a function. So we have two outputs or inputs, I apologize, inputs going to one output, this is still a function. So this is a function. That is a function. Alright? It's because we don't have one input going to two outputs that would make it not a function. And we don't have that case here. So now we can go ahead and move on to the next part of this lesson. Now we're going to go ahead and talk about graphing equations in two variables in that three-step process I mentioned. The first step that you're going to have is to construct a table of values, alright? Make sure that you guys are picking values that make sense. Try picking a few negatives in there. 0 is always usually a good option unless it doesn't make sense to use 0 because it's not in your domain or those x values, like in a situation that we'll have later on in the classwork. And then also try some positive values, alright? You want to get that full spectrum to find out what your function is going to be doing, alright? The next piece is to plot enough from the table that you've made to recognize a pattern. Make sure that when you're making these points that it'll make sense. We're not going to have too many crazy graphs when we're graphing these two variable equations, alright guys? So make sure it makes sense. And then your last step is just going to be to connect those points with a line or a curve, alright? We're not talking about connect the dots stuff where you'll make a little smiley face. We're not talking about that. Usually we'll get what's called a linear function, which will be a straight line, or we'll get a curve that looks either something like this or possibly something that looks like this. Alright, guys? And that is the three-step process. So we'll go ahead and move on to trying an example. So if when the example screen comes up, you can go ahead and try and pause here so you can try it yourself and then resume it when we can go ahead and start this example. Alright, so welcome back. We'll go ahead and try this. Make sure when you guys are doing this you try that full spectrum of values, remember? So I'm going to go ahead and try -1, 0, 1, 2, and 3. Alright, and when we do these, make sure you guys are plugging them in and following your order of operations. So when I plug in -1 here, I get -2 times -1 minus 1. And as I know, -2 times -1 gives me a +2. Then when I subtract the 1, inside this table for my y value for -1, I'm going to get just 1. When you do that for each one, you should have gotten something along the lines of -1 for 0, -3 for 1, -2, or -5 for 2, sorry about that, and then -7 for 3. Now that I have these values on the table, I can go ahead and begin plotting them. My step 2, I can begin plotting them. So I draw my axes on my graph paper here. Draw my graph on there, and then I'm not going to label it this time. I'm just going to let you guys know that each line is worth 1 unit. 1 unit. So at my point -1, I go back 1 and up to 1. I'm going to go ahead and use a green for these points so we can start seeing the differences there. And then my next point was 0, -1. So I'm going to come down here. Then I had 1, -3. So I go over to 1, down to 3 here. Down to 3. Over to 2 and -5. Alright? And this is where I have enough points because I can start to begin to see a pattern, and I'm not even going to be able to fit that -7 onto my graph. So I can go ahead and stop here and begin with step 3, which is connecting those points. So I'm going to switch to a different color and show that since I have this pattern, I know that it's pretty much a straight line straight through those points. It's a little off. I don't have a ruler with me, but you guys are more than welcome to use that ruler. Alright? Now another key piece of this is you'll be asked things like, what is the domain of this function? What is the domain of this function? Now, since we have an equation where it says y equals, we know that we can plug pretty much anything into that x, right? So when we plug those in, we know that it'll generate an answer for us, so that our domain for this one will be all real numbers. All real numbers. Alright? And if our domain is all real numbers, when we put those in, since we can see that this graph is going all the way up and all the way down, because it'll have these little arrows on them, and it goes on forever and ever, we know that for a range, we'll get the same thing as our domain. We'll get those all real numbers. All real numbers again. It's important to see when you're going to have your domain and range stop and when you're going to have this all real numbers solution. Alright? It's another important part to recognize when that graph will continue on and when it'll stop. And we'll take a look in that real world example later on when it actually. Now, an important part to recognize here is when we got that line, we're going to call this a linear function because it created a line. Pretty crazy, right? So what we need to see here, and I'll go ahead and highlight it in green and box around it, is right here. So because we just have this x term with no power, our power is just 1, we know that it was a linear function, alright? It was a linear function because it had this just x value here, alright? Because now we're going to look at classifying these functions in an example. So we're going to need to tell whether or not this linear functions or not. Are they linear functions or not? So go ahead and try that in this next 2 examples. And go ahead, pause your podcast now, so that you can attempt these problems and we'll work them together after you've given them a try. Alright, so make sure to answer the questions. Is the function linear? And then evaluate that when x is -4. Go ahead and give it a try. Alright, I hope you guys understood those, and if you need to watch to make sure that you got them right, let's go ahead and do this step by step. The first question asks if it's a linear function. Is it a linear function? Your answer for this should have been it's not linear. Not linear. Sorry there, this pen is getting more difficult to use each time, I think. And the reason that you got not linear for this now is because of this x squared term that we have up here. This x squared, since it's squared, we know it won't provide a line when we graph it. It won't be linear. So then it asks us to plug in that -4 for x and to evaluate this function when our x is equal to -4. So we write out that whole problem, right? The whole problem. Now when we square that -4, because we do the exponents before we multiply that negative to it, we're going to get 16. Then we bring in the negative, so we're going to get -16 there. When we plug in 4, sorry, this should have been a 4. Should have been a 4 there. And so the -4. And so when we multiply -2 times our -4, it gives us a +8. And we still have this +7 out here. Now I know that +8 +7 is going to go ahead and give me 15. So I know that I'll end up with a -1 for an answer here. A -1. Now the important piece to look at is right here. We don't have anything else except for this x term to the first. Right? All the 8 does is shifts it around a little bit. We're looking for x's, and since x, the only one we have is just an x, we know that this one is linear. Is linear. Alright? And then once again, even though it's linear, it still wants us to evaluate this when it's -4. So we go ahead and plug our -4 in there, and we're going to get negative 20 plus 8. So negative 4 times the 5 gives us negative 20. When we add these two together, we end up with a negative 12 is our answer. Alright, you guys have all evaluated these functions before, but you've never had to label them as linear and not linear. Alright, so it's important to remember, right here is why it's not linear. And since we don't have anything else added to it, we know that this will make it linear. That is the important part. Look for those x values. If you add squares, cubes, x to the fourth, it won't be a linear function. You can only have a single x term in there. Alright? You can have multiple of those x's as long as they're not being multiplied together. You need a single x. That 5 out in front doesn't actually change anything from it being a linear function. So you guys know. Now, we'll go on to that real-world example where I'll give you guys the chance to do this on your own. Alright, so go ahead and read this over, pause it, give it a try, and then we'll resume back. So go ahead and pause now. Alright, so solving this problem, we like to make sure that we know every bit of information before we fully get started, so we need to read carefully. So a diver using a propulsion vehicle descends to a depth of 130 feet. So the deepest that he'll go is 130 feet. So I know first off that the last one that I want to try in here on the table is going to be 130 feet because that's as deep as he's going to go. Now, the pressure in atmospheres on the diver is given by P of D equals 1 plus 0.03 D, where D is the depth in feet. So it's asking us to graph the function and determine a reasonable domain and range. What is the pressure on the diver at the depth 33? So the first thing that we're going to do so that we can graph this is pick a table of values that we're going to try for this, alright? So since we can't have a negative here because we can't go above the water, which would technically be the negative part here, we're going to go ahead and start it at 0. We're going to start with 0 and say what his pressure would be if he didn't dive at all. So then we need to pick some values in between, and I like to kind of spread them out a little bit, and so I'm going to go ahead and choose 40, 80, and then 100. And as I said before, since the deepest that he goes is going to be 130, I'm going to go ahead and make that my last one so I can see where my graph is going to stop. Alright? Where that graph is going to stop. So, the next thing that you need to do is you need to plug those values that you got for D into this equation, 1 plus 0.03 D. So when I plug in 0, I know that 0 times anything is 0, so I get just plus 1. Plus 1. When I stick 40 in, 40 times 0.03 gives me 1.2. I add 1 to that, and I know that I get 2.2, right? 2.2. When I plug 80 in, I end up with a value of 3.4. I'm going to go ahead and do this quick because I have them written down. You guys would generally need your calculators for this one because, let's face it, that's what we like to use them for, right? Right. So our last value we're going to get is 4.9. 4.9 in there. Alright. So with these as our values, we're going to go ahead and set up a graph now. Alright, so I draw my axes down. I know in this case, since my D is my input, not using X, I know my D axis is going to be here. My P of D axis is going to be the one going up. Alright, so since we know that we can't go by ones here because we make it all the way up to 130, we're going to go ahead and use some different values. So we're going to start with 0, of course. Then we're going to jump right up to 40. I'm going to jump up to 40. And then we're going to jump to 80, since these are our values. There's a reason I picked them that way. Then we're going to go to 120, which is our next one, followed by 140 after that. Alright, 140. And then on our way up, we are going to use that interval of 1. The interval of 1. So we're just going to go up 1, 2, 3, and 4, and then up to 5. So since we've picked these, we can go ahead and start plotting our points now. We know that our first point is 0, 1. Now I'm going to go ahead and switch to a different color now so you guys can see these a little better. My first point is 0, 1. My next point is 40, 2.2, which is right about in there. Then I have 80 and 3.4, which is almost halfway. And then the 100, I need to be careful now because 100 is going to be perfectly between 80 and 120. So I know that that 100 was right in between there at 4. And then my last value, which will be between 140 and 120, will be almost at 5. So that mid value is right in there. Now I'm going to follow that third step, and I'm going to go ahead and draw my line in. Draw it right in there. Alright? So the next piece that it asks is for the domain and range. So when I get my domain over here, which I'm just going to label with a D, I know that my domain will be anything in between 0, because that's that starting value. And it can be equal to 0. And this is going to be my D value in here. But I know that it has to be less than or equal to that 130. That lowest that I'll go, that 130 feet deep. Alright? So that should be your domain, alright? See how it's not all the real numbers this time? And it actually stops at 0 and 130. Then we need to discuss the range. The range, which I'll label with an R there. And we know that the range this time doesn't start at 0, but the lowest value that we can have is actually 1. And we know that, once again, that our P of D can actually be that 1. So we're going to have that equals to. We're going to take it to the highest value for our domain that we used was 130. And the highest range we got out of that was 4.9. 4.9 that we can see on the graph. So we know that that's our top for our range. Now the last piece that it asks from us is to solve for when the pressure, or solve to figure out what the pressure will be when the diver is 33 feet deep. So all we do is plug that 33 in, and when we do that, we got 0.03 times 33. We get, when we do the multiplication, we get 1 plus 0.99. So we end up with 1.99 atmospheres, which I'll label with an A. Label with an A. Atmospheres. You guys should write it all the way out so that we know that it's atmospheres, but I'm not going to try and do that with this pen this close to the end. So, that is the lesson for Chapter 2.1. This is a little longer one because it's my first time. I apologize for any screw-ups, and it's hard to read a little bit, and I promise that I'll get better with this pen. So, good luck on this lesson. I'll see you guys in class. Yay!